Okay, so today I am attempting to explain functions and specifically looking at domain and range, which is probably one of the more complicated aspects of Cambridge. I say Cambridge because domain and range are fairly simple concepts, but the way in which they're assessed in Cambridge can be quite difficult, and often there are only 1 or 2 marks, but they can be really challenging. This video is for Catherine because she has requested it. So shout out to Catherine. Everyone wants a shout out now. It's very important. Okay, so we're going to go through just basic functions and what their domain and range would be, and then we're going to look at some specific examples. So first of all, I'm going to go through the 4 different main types. So linear, surd functions, quadratics, and rational functions. Just looking at a linear function straight away, linear meaning a straight line. They're pretty simple. You're just going to talk about their domain, which, if we haven't already realized, is all possible x values. So they're like the inputs of a function. So what values can you put into a function? So if we think of a line equation, it's usually of the form y equals mx plus c, something along those lines. Any x value can be put into that function. It's no problem at all. So we say that it is x is all real values, that like capital R with the double barrel is all real values. Okay, so essentially x can take any value at all. And then if we look at the range, the output, which on a graph is the y values, what possible y values can come out of that function? So what are the output? So if we think of this one as the input, what things can come out? Again, it's everything. Y is all real values. Just a little tip, if you tend to get confused between domain and range, domain is the x values, range is the y values. The way I remember is range has the letter G in it, which has a tail, as does y. So I always just see the tail of the G and think, oh, that's the y. Okay, so lines, all possible real values for both x and y. Now, the next one we're looking at is surds. You might be thinking, what on earth is a surd function? Surd is like a really fancy way of talking about a square root function. So it could be something like that. Okay, something with a square root in it. So when we think about x values that can go into that function, hopefully you're kind of thinking there's going to be a problem. And you can see the problem when you look at the x values that can go in it, because it very obviously stops just here. And so this particular function here doesn't allow any values less than -1. And so what is it about the function that could cause that to happen? Well, with a square root function, you cannot have negative numbers underneath the square root. So if we look at under here, that has to be positive. Okay, so if we're looking at this specific example that I've actually shown this graph here, is y equals the square root of x plus 1. So if we're trying to solve this and work out what are the possible values, we would write something like, well, x plus 1 has to be positive. So to write positive, we can say it's greater than or equal to 0. And if I just move that over, you can see that x takes all values greater than or equal to -1. So the domain is from this point up. Okay, so for all surd functions or square root functions, you want to make the square root positive. So whatever is under the square root, you want to set that equal to a positive number, meaning greater than or equal to 0, and that will help you find the domain. Now, probably the easiest way to find the range for this is by substituting -1 in. So if you put the smallest possible domain in, it's generally going to give the range. Okay, so if you look, if we put -1 in there, we get the square root of 0, and so the smallest possible value is 0, so it's y is greater than equal to 0. If we had like a slightly different equation, say we had y equals root x plus 1, but we had a plus 3 at the end. Well, the smallest value of this bit would be 0, and then we can add 3. So the range for that would be greater than or equal to 3. Okay, so the domain, we need it to be positive, and the range we put in that domain that we have, and that will produce the range. In saying this, all graphs are slightly quirky and different, and if you draw a picture of it, it's always going to help you. So if you can draw a quick sketch of what the graph will look like, it's always going to make you feel more confident with them. Right, our good old quadratics. Quadratics, we generally in Cambridge are looking at quadratics being in the completed square form. So usually in the question, they ask you to do the completed square form first. And that allows us to find the domain and range really easily. So if we look at this particular question, looks like the vertex is at 0 across and 1 up. So the equation would be y is equal to x minus 1 squared, and you can think of that as plus 0. Oh, sorry, did that the wrong way around. So it would be x, you could think of it x plus 0 squared, but it's plus 1 on the end. So it's just a normal parabola that's been shifted up by 1. So the domain for parabolas, and you can't tell so obviously here, but any x value can go into it, okay? Because I can square any x value. There's no problem with that at all, unlike the square root function. Okay, so for the domain for quadratics is that x is all real values, just like it was for linear ones. And we'll talk later about restricting the domain and things. However, the range isn't everywhere. You'll see if you look at the y-axis, you know, it has values here, 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 and suddenly it stops. Okay, and what is that value? Well, that is the vertex. So when it's what I call a happy parabola, meaning it's positive x squared, y is greater than or equal to 1. And when it's an unhappy parabola, I'm talking about 1 because I got that 1 from here, then y would be less than or equal to whatever that y value of the vertex is. So you just got to look at the y value of the vertex. So if I gave you a different question, let's say just made a parabola up. So that parabola is happy. Its vertex is at -2, -4. So its range would be y is greater than or equal to -4. Okay, so from the y value of the vertex up. If it was an unhappy parabola, if I just simply put a negative in front of it, suddenly that would be y is less than or equal to -4 because it would be a parabola looking like that. Okay, so it's all to do with the y value of the vertex. So that is quadratic. So quadratics, domain, everything, range, y value up, y value down, depending on whether it's a happy or sad parabola. The last one we're going to look at, we call rational functions, but you might think of them more as fractional functions. They are called hyperbolas. Just like a quadratic produces a parabola, a fractional function will produce a hyperbola. Now you'll notice that pretty much it exists everywhere for x and everywhere for y. So if we're looking at the x values, it's all good. And it's all good, but we have this section here, and this is called an asymptote, where it doesn't actually exist. Same with on the x-axis. So when we talk about the domain, we'll say it's all real values, but it will not equal, and in this case, judging by the scale, it looks like x will not equal -1. Okay, and the range, same thing, everything, but it does not equal, whoops, y does not equal 0. Okay, now why would that be? What is it about a fraction that could be an issue? So this particular equation, I don't know what it is exactly, but let's say it's of this form. So hopefully you can see if I happen to put this -1 in, I get 1 divided by 0. And we know that when we divide by 0, math breaks. Okay, so we cannot have 0 on the bottom. So if you're given the equation, say they gave you y equals 1 over 3x plus 2, and they said, what's its domain? You'd say, well, it's all real values, but 3x plus 2 cannot equal 0. And then you'd solve that little mini equation. So 3x cannot equal -2, so x is not equal to -2/3. I don't know if that's called solving an equation or solving a non-equation. It's like the opposite of an equation. Okay, so it's all to do with the denominator not being able to equal 0. And then hopefully it makes a little bit of sense that whilst when I divide 1 by a really, really big number, 1,000, I get really, really close to 0, but I never actually reach 0, which is why y will not equal 0 for the range. Okay, so that would be the same thing for this graph here. So it can never equal 0 because even though this value gets really, really big or really, really small, when I go 1 divided by it, I don't ever quite reach 0. So that's just the basic 4 types. They're probably going to focus on quadratics, but you never quite know what they're going to do. And it's best to do, as usual, lots and lots of examples. And if you can, try and draw a picture. Just to follow this up and hopefully kind of consolidate some of this, I just want to go through, this is a 2021 paper, I believe. Let me check. Yeah, 2021 paper. And it's just going to go through everything that we've just talked about in terms of functions, but with a specific question and just to kind of highlight some issues that can happen. So the very first question, and this is so common, and you're going to complete the square, I don't know, 2 or 3 times in every single pure paper. So the first thing is just to complete the square because that's going to help us later on with finding the domain and the range. So this one's got a -3 in front. So I'm just going to factorize -3 out of the first 2 terms. Oh, I don't want, I'm doing too many brackets. And then once I've factorized it out, I'm then going to complete the square of these first brackets, which is when I do need another bracket. So halve that number, subtract that number squared, and then that 2 still drops down. And then lastly, you just need to multiply that 3 back in. -3 times -4 is positive 12. So we get -3x minus 2 squared plus 14. Now, I know it doesn't say to do this, but when I look at that, I would probably just think to myself, right, it's an unhappy parabola and its vertex is at 2 and 14, just to give me an idea of what's going on. And you just get a mark per, so if you get that correct, 1 mark, that correct, you get 1 mark. Oh, it says the one-to-one function. We didn't really talk about that. So the one-to-one function means that for every x input, there is 1 y output. So when you look at a parabola at the moment, this little sketch that I did here, let's just give it an axis. Can you guys see that, like, say for this x value, there's a y value, and I get the same y value here. So that's not a one-to-one function because both of these x values are giving the same y value. So there's many x values giving the same y value. So it's not a one-to-one function, which means it won't be able to produce an inverse because functions are only allowed to have 1 input and 1 output. That's not entirely true. But when we do an inverse, in order for it to have an inverse, it needs to be a one-to-one function. It's probably the easiest way of saying it. So with this one, it's saying that it's defined and it's what we call restricting its domain. So this is a domain restriction. And it's restricted the domain so that it has become a one-to-one function. So it's essentially saying, where can I cut the parabola so that it is a one-to-one function and not a many-to-one function like it is currently? And you're always going to be cutting it at the vertex. Okay, just like with the range, we're worried about the vertex. Everything is about the vertex. So what we're wanting to do, and you can see it's less than, it's saying, hey, look, I want to chop this and just keep the left-hand side. And where should I chop it? So I can chop it anywhere along here, but it's saying the largest possible value. So the very biggest I can get to is x equals 2, because once I start going over onto this side, it starts repeating and I start getting 2 x values producing the 1 y value. You'll notice that it uses the word state. State means that the answer is clearly obvious, either from the work you did before or from the question. Okay, so they've restricted the domain to make it one-to-one, and when we restrict the domain to make it one-to-one, it's always at the x value of the vertex. Now they say that k is equal to -1. So if we take that picture, we've restricted it just before by saying x was equal to 2, and this point here was 214. Now it's saying, actually, we've decided to make k equal -1, so we're going to move a little bit further over here to -1. And we're now cutting it so that we've only got this little section here that presumably will continue on into eternity down that side. So if we want to know what the range is going to be for this function, we need to put -1 into the equation. So put -1 into it so that we can find out what this coordinate is, because at the moment I only know it's -1. I don't know how tall it is. So if you chuck that in, you're going to get -3 minus 12 plus 2. So we get -13. So y, or f of x, is less than and equal to -13. I use y and f of x interchangeably. They're not too worried about that in the Cambridge exam. Just to highlight a little bit more, the range for this one, if we hadn't, so forgetting any domain restriction at all, the range of this one would have been y is less than or equal to 14, f of x is less than or equal to 14. Okay, but then because we restricted the domain, it changed. Finding an expression for the inverse. Remember, when we're doing an inverse of a quadratic, you always have to do it from the completed square form. So -3 x minus 2 squared. I've already forgotten it. Was it plus 14? Yes, it was. Y equals. So we want to do it from this. We don't want to do it from the expanded form. So switching them around. And then you're just trying to make the new y the subject. So we move the 14 over. Square root. No, we want to divide by -3 first and then square root. And then add the 2 over. Now you might be sitting there going, why has she negative square rooted? So at this point, I could have done plus or minus, which is fine. However, because this function only exists on the left-hand side, it's only going to produce the negative. Okay, so if I had the right-hand side of the parabola, this is just a generic parabola. So let's say y was greater than or equal to whatever value, it would produce the positive square root. But when I'm doing x is less than, it's going to produce the negative square root. Okay, so when you flip them, so the inverse is when you flip them in the y equals x line. This is the right-hand side of the parabola. When I reflect it, it's going to produce the top of the surd, so the positive square root. And if I took the left-hand side of the parabola, when I reflect it in that line, it's going to give the bottom of the square root function, so the negative square root. Last but not least, transformation questions. They started coming in from 2020. So if you want more practice on them, you've got to focus on 2020 onwards. They've transformed it -3, 1. I always find it easier to take it from our normal completed square form, because that's just how I like to think about things. So we said quite comfortably before that the vertex was at 214. So if we translate that, it's going to move 3 to the left from -1, and it's moving 1 up. And then I just chuck that straight back into my formula. So it's going to become +1 and +15. If you forget to change the sign, just remember, if it's in brackets, you change the sign. Okay, if it's not in brackets, you don't change the sign. So that's the new one, but of course they wanted it in this form, so you will need to expand it. And if you do that, you will get the right answer. And it's worth expanding it and doing it properly, because it is worth 3 marks, which is quite a lot in a pure paper, really. And that was your final answer. Okay, so hopefully that helps consolidate some of it. I know it's a really tough topic, and this was only just covering a few of the details around it. I do have some other tutorials on the channel about functions, so maybe have a look at those to help understand it, and feel free to hit me up with a question if you want me to focus on something more specific in my next tutorial.